I have a ton of errands that I have to do today. I have to go by the bank to REI, go to the grocery store, get some gas, and pick up a card for my mom. What is the best way I can do that and be the most efficient? Why do people touch their chin when they're thinking of things? That's just weird. I don't know. Why do people shrug their shoulders when they don't know something? What? Wait, wait. Just focus. Focus. The best way to do something. I wish there was a math that could help me.
There is. It's called graph theory. So, what does graph theory do for us? Graph theory is a way of organizing if we have multiple tasks and things that we have to do, and maybe a specific pattern in which we have to do it. Graph theory is a way of organizing all of that so that we can better be more efficient with our time, be more efficient with our information, be more efficient with things like that. An example of graph theory would be in organizing our daily trip. So for instance, I'm getting ready for a camping trip. So what do I need? Well, I need to go by the bank to get some money. All right, I need to go by the grocery. I need to go by REI to pick up a few extra supplies. I need to go by and top off my gas tank. Oh, and I can't forget, all right, I got to pick up a card for my mom. Hallmark. So I got to go by Hallmark. Don't forget your mothers, people. They're important. All right, don't forget your moms. All right, good stuff. All right, so I got to go by Hallmark. Here's the problem. Here's where I live. Right, the grocery store is over here. Let's see here. Down this road, I've got. There's the gas station, but here's REI. It's way down here. Let's see here. The bank is kind of in the middle of all that, and the Hallmark is off on this other road over here. Right? So the key is there a way that I can make this most efficient? Because I don't want to go from home to the grocery and back, and home to gas and back, and to REI and back. I don't want to have to be jumping around. I know I've got to go to the bank first because I've got to get money to get everything else. So my first trip would be from here to there. But from there, where do I go? Do I go ahead and zip down to Hallmark and back? But that runs me back on this road, running me in the same one. Or do I go to REI and get gas because I do need to fill up? Is there a way that I can connect these things, right? So to better manage and make things efficient, we can take all this and we can break it down into more like symbolic, because that's what mathematicians are really good at. Let's take the real world and let's make it symbolic so that we can make sense of it. So let's do that. So we can simply set up a nice little pattern where we have a hub here. That's our home. We have a hub here. These hubs, by the way, have names. They're called vertices. A vertex singular or a vertices. Okay? That is what these things are. And they are connected by these pathways. These pathways are called edges. So I'm going to connect up these edges if I can. Let's do it that way. Now I'm doing it this way because I think this is what's going to make the most sense. You see, I have to go to the bank first, so I am going to go to the bank. But then if I go ahead and fill up my tank and go to REI, if I can get from there back to Hallmark, I could then make it back home. So this would give me a one route path. Doesn't really follow those roads, but I can maybe find some back roads to do that. The key is with the grocery store, it's really on the other side of town, so I have to go out of my way to come back for that one. So that one's going to have to be a round trip. I'm going to have to go that way and this way in these paths, right? So if I can set this up in a way that I can organize, now I'm not bouncing around, now I'm making efficient use of my time and everything else. I want to go to the grocery last, by the way, because I got milk and other stuff, and I don't want that sitting in my truck during this whole trip. So that's got to be the last stop. The bank's got to be the first stop. Everything else is kind of flexible. So really in here was where I was able to make decisions. So that's the idea of the way that graph theory works, is it enables me to become very, very efficient in organizing networks of things. Now, where else does this work? Well, if you're dealing with information that's traveling in computers, if you're dealing with a network of individuals in an office, if you're dealing with directions and roadways, if you're trying to be efficient in your time at the grocery store, at your time in REI, if you're trying to be efficient, then you want to know the layout of that grocery store and you want to be able to follow that pattern. My wife is a genius at this. When she gives me a list to go to the grocery store, she always gives it to me in order of produce to dairy, which in the store we go to is one side to the other, and I don't have to backtrack at all because she knows that store and she makes it very efficient for me. She just intuitively does map theory like no one else. It's amazing. So what are some important terms to know when we're dealing with map theory? Well, we already talked about the vertex, that is a point, and then we talked about an edge, and that, in a sense, is a bridge that connects those particular points. The other thing that we want to know in dealing with map theory are the degrees. Each of these particular edges has a specific, or each of these vertices has a degree of vertex. That degree of vertex is the number of paths in and out. So here, this particular vertex has a degree of 4, and all the rest of these have a degree of 2. If I were to change and draw one like that, just to mix things up a little bit, then this one would now have a degree of 3, and this one would have a degree of 3. The cool thing about this is if we have 2 odd-numbered vertices with a degree of vertex that have an odd number and only 2, we will be able to do that entire path without ever taking the same edge twice. The key is you've got to start on one of the odds and you can end at the other odd. So I should be able to start here, and let's see here. If I go from here, I can go from here to there. I can go from here to here, from here to here, from here to there, from here to there, from here to there, and from here up. And I never crossed over the same edge twice. I did, and I hit every single point. That is a special type of graph that we will talk about in a different video. Check out the video I have on Euler versus Hamilton. I think you'll like it. Graph theory. Great way to organize and plan out your day and your tasks to be amazingly efficient.